Hello and welcome to another one of D's ADD videos. Today we're going to be looking at London dispersion forces. What are London dispersion forces? These are forces that basically give rise to intermolecular forces in nonpolar molecules. And they give rise to these Coulombic forces by electron movement. They're the weakest of the interactions as a result because they're based on this phenomenon that's temporary. The electrons move, but then they move back. So they create what is called an instantaneous dipole. So let's see it in action. If I were to have this electron move, let's say it was here, and then it just moved to the other side over here. Now I've created an asymmetry of charge within this particle itself. So this asymmetry of charge ends up creating this instantaneous dipole that I spoke of. And if you remember, this lack of electron density here would create a partial positive charge. And then this would be your partial negative charge. So your shorthand for dipole notation would create something that would look like this. Sorry about the clicks. My tablet's temporarily not working, but we'll make do. Now what happens is after this instantaneous dipole is created within the particle due to this transient or temporary action here of the electron movement, now what happens is the adjacent molecule ends up repelling electrons. So we look at if we were to look at the adjacent particle, right, whatever it is, whether it's a gas or a liquid, they're going to have particles within that phase that interact, and this is the weakest of the interactions. And these electrons here get repelled by the movement of this electron in the adjacent molecule. Now these other electrons move on the adjacent particle, and they themselves have, by their movement, created another dipole. This dipole is referred to as a induced dipole. Okay. So, one more time. Electron moves, creates an instantaneous dipole, partial positive where the electron was, partial negative where the electron is. And then the adjacent particle, electrons get repelled by that electron that's over here and create a dipole that's called an induced dipole. Now, because I have a partial positive charge here, I'm going to have some attraction going on between this electron deficient region and this electron rich region. So we're going to have a little attraction happening there. So what ends up happening is the instantaneous dipole will end because the electron will move back, and then that repulsion of these electrons will no longer be there, so they will move back eventually, and these dipoles will no longer exist, and then these particles will no longer be attracted to each other. Okay? So you can see why this is a weak force. So the final thing we should discuss when discussing London dispersion forces is the term called polarizability. This refers to the fact of the movement of electrons is much easier in a larger particle than it is in a smaller particle. If you think of a smaller particle like fluorine, the electrons are tightly bound and therefore don't move as much. There will be less instantaneous dipoles occurring. Whereas a bigger halogen, like iodine for instance, would have electrons that are loosely held on the outside, and they thereby can move more readily, creating larger dipoles and more of them, and therefore more London dispersion forces. So the larger the nuclei, the stronger the London dispersion force. All right, it's said to be more polarizable. So when you're done with all this, you should be able to determine which molecules have stronger London dispersion forces. You should also be able to recognize the concept of an instantaneous versus an induced dipole. There's another ion dipole that differs, that people often also confuse ion dipole with induced dipole or instantaneous. That is a completely different topic that I will discuss in a different video. All right? So make sure you practice a few of these examples. Check out the example videos. It's not too bad once you get the concept. I hope I have eliminated any doubts or concerns you might have and given you enough information for you to start thinking clearly about London dispersion forces. Thank you and have a nice day.